So this was also a part that cut off as I was going in between a PowerPoint and some PDFs. So we saw the basic geometries of a bunch of different molecules that we can have, and it was nice to see written in a sphere so you can kind of see the projection, but we don't usually write it that way when we do VSEPR. So you're going to see some different ways of showing something to be in 3D, and we'll get to that. First, we want to see that, okay, we covered this first column, which are the basic geometries, and all these words should sound familiar now, but there are a bunch of different projections that we can see here that we didn't get to. So the different shapes that we can have exist because now we can also have lone pairs. So the basic geometry, or if we look at our assignment, we call it the group geometry, can be separated more into molecular geometry. So depending on how many electron groups we have, we're going to be in linear, in trigonal planar, in tetrahedral geometry, but when we do have lone pairs, we can add a new name and then call it molecular geometry. So linear, we're not going to have lone pairs with anything. If it's linear, there's no other types of geometry. By the time we have 3 electron groups, we might have a lone pair. And so if we do, that's going to show us a bent geometry. Remember how we said that lone pairs take a little bit more space? That's why we're now seeing it saying less than 120 degrees. So don't worry too much. We can still just say 120. It's very, very slight. So we'll now have a bent geometry. Tetrahedral, which seems to come up pretty often. If we have 1 lone pair, we now have a trigonal pyramid or a trigonal pyramidal, depending where you look up. It's kind of like a little tripod. And if we have 2 lone pairs, like classic water or something like that, we typically call it bent, or depending where you're looking, you might call it angular. So, of course, 1 lone pair, our angle's getting slightly smaller than it was before, that 109.5. And if we have 2 lone pairs, they take up even more space themselves, and that's why they have a double lesser than sign. Once we get into tetrahedral, we're really looking at that 3D-ness, right? It's no longer on a singular plane. We just don't have sticks showing our bonds. So this is where these dashed lines and these wedges come in. So dashed lines mean that they're projecting away from us, like into the screen, into your page of paper. And a wedge is showing us that it's projecting towards us or out of the screen. And you also have this in your lesson to show you kind of that kind of stuff. So the dashed lines and the wedges. A normal bond is just within the plane. Things get crazier when we get to 5 or 6 electron groups. So we saw this written in a sphere and it made it a lot easier to look at. But here are your axial bonds going up and down, and these ones are the equatorial ones. And so we've got 2 different bond angles now, the 90s if we're going between axial and equatorial, and 120, anything in the equatorial positions. We can have 1 lone pair, 2 lone pairs, 3 lone pairs, and as that happens, our names also change. So linear is easy to see. We've got 2 pairs here, 2 bonds here with 3 lone pairs. T-shaped, it's obviously written sideways, but here's kind of our T, capital T, and a seesaw also turned on its side, kind of like at an old school playground type thing. And then octahedral, so we can have them completely filled. If we have 1 lone pair, we now have a square pyramid. If we have 2 lone pairs, it's all the equatorial region taken up. A T-shape pops up again, harder to see because of the projection written here. And then again, we could have linear. So just one thing to remind you about how we were looking at hybridization. Hybridization doesn't change though. So all of these will still be SP. Anything in this row would be SP2. If your steric number is 4, SP3. SP3D, and SP3D2. Also in our assignment, I just want to make sure that we put everything in the right spots, so this final column doesn't get touched until lesson 5. So you'll use the same assignment pretty much for both lessons. The biggest part of this is obviously just drawing your Lewis structure right, because everything else can come from a chart and you can look it up. So these two columns end up being the same here because we have no lone pairs. But if we did have lone pairs and all this information is the same as that previous sheet, if we did have lone pairs, say if we had one lone pair, we're still going to have tetrahedral for that first column, the group geometry, but in the second column we'd write trigonal pyramidal. So everything in this column, or sorry, row, is tetrahedral for group geometry, but if you're looking at molecular geometry, it's going to be these specific names. Okay, everything in this row is octahedral for group geometry, but if it has 4 lone pairs, its molecular geometry is going to be linear. Make sure when you are drawing your Lewis structures that you include all your lone pairs, just like you did in your homework assignment for that. And then your sketch is always going to make sure to show the projection. So make sure you do have those straight lines if you're in the plane, dashed lines if you're projecting inwards, and wedges if you're projecting outwards.